Okay, we should be live. So hello, everyone. Thanks for joining us. So this is Uncubed's webinar. It's called How Technology is Changing Your Students' Future. So it's a webinar by Uncubed, and today we have a really special speaker. It's Donald Ferguson. So Donald Ferguson was Vice President and CTO at Dell. He was also a distinguished engineer and a VP at CA Incorporated. He was also fellow at IBM from 1985 to 2007 and at Microsoft. And he's currently a computer science professor at Columbia University. So yeah.
Thank you for having me.
Of course, thanks for being here. And for those of you who don't know, I'm Kalisa. I'm an intern at Uncubed, and currently I'm also a student at Columbia University. Something that I just want to say before we start the webinar is if you look on the right-hand side over here, we have like 4 tabs over there, and you can click on them if you want. We have our 2 other webinars, which is a resume webinar hosted by Chanel, and then another upcoming one with Scott Bacon. It's about recruiters in the tech industry, and he was a recruiter at Google and Cruise Automation. We also have the other 2 tabs underneath that for Uncubed entry. We hope you can add some of your students onto that list, because it's just all the internships and jobs for your students. I hope they'll enjoy that. We also have HR Uncubed, which is our big event. You might have heard about it. We have all the HR staff from across America, from tech industries that come, and you get to meet them, and it's a great event. We hope you can join us. And we hope that you also ask questions throughout the webinar. We do have, if you go to the bottom right corner of the screen of the video, you can click on the tab that reads open in YouTube, and you can ask questions through there. So we'll answer your questions at the end, but if you do have any questions during the webinar, just add them there. So yeah, I guess we're ready to start then. So yeah, I mean, I'd love for you to just introduce what you've done before, just introduce your work to the audience.
Okay, well, you did an excellent job of it. I'm not sure.
Yeah. Yeah.
I got a PhD from Columbia in computer science in 1987. I spent 10 years doing applied research in computer science in the research division of IBM. I came up with a project that IBM wanted to turn into a general software product, so I transferred to the IBM software group. And the product became, it's a product family called WebSphere. It's a web application server in Java. It's probably a multi-billion-dollar business inside IBM right now.
Wow.
In 2001, I became an IBM fellow for my contributions. After 20 years at IBM, I decided to do something different, so I went to Microsoft and became a technical fellow. I worked on their strategy for software for businesses, and also on some very early work that started to feed into their cloud platform, Microsoft Azure. I spent 4 years at CA Technologies, which is a company on Long Island. I was helping them modernize their software, move into cloud computing, virtualization, security. And then I spent 3.5 years at Dell, helping them form a software group to complicate the hardware business. I've been an adjunct professor at Columbia for many, many years. I think I've probably taught maybe about 12 classes, mostly graduate classes. But I decided that I'd had enough. Being an executive in a large corporation was trying to do something else. I left Dell and did a startup. I'm still doing the startup on the side, which was a lot of fun. It's unlike anything I ever did. It's a small company that does basically it's a platform that allows independent web TV series to stream and build an audience. And then in January, I decided that I was going to become a full-time professor of practice at Columbia. And so I've been doing that for about a month now.
Yeah, that sounds pretty great. It sounds like you've been on both sides of the spectrum, like education and then very corporate environments. So you've been around for a very long time. It seems like the whole industry has changed. What would you say from your experience, which skills do you think have been very instrumental to your success, and which ones seem to continue to be the ones that are wanted by companies even after so many years?
Put it into 3 categories. The first one is it's not something that you would typically think of as an engineering or science skill, but it's the ability to communicate effectively. It took me a long time to master that because you don't really learn this in college or graduate school. But the ability to present, to talk, to communicate ideas, to be comfortable in front of a group of people, surprisingly, is probably the most important skill for career success. You can do wonderful work, but if you can't explain it or convince people, if you can't feel comfortable up in front of a room, it's going to be very hard to be successful, and it's going to be very hard to get your ideas to move forward. In my graduate classes, I try and do some training, to give the students some experience presenting projects, doing project reviews. But universities and schools do a very good job of the core academics, technical projects, but communication, how to function effectively in a meeting. I think it's important that young students master those things much sooner, because it is a very steep, hard learning curve when they get into the workplace. So that one's not core engineering. The second one is, despite all the advances in technology, the nucleus of science and engineering remains the same. There's a core set of mathematics. There's a core set of science, and there's still a core nucleus of computer science. So we've seen incredible transformations in terms. In my career, I've seen mainframe to PC, PC to internet, internet to mobile. I've seen cloud emerge, and now we're seeing artificial intelligence. There's still a core nucleus of skills. The technology changes around them, but the core nucleus of understanding algorithms, understanding basic concepts in software engineering, data structures, basic mathematics, that really hasn't changed. So it's that core nucleus, I think, is important. And the other one that I found useful is, despite being an engineer, I actually went to Columbia College, and so I went through the core curriculum, and you learn to think and reason, and just do it in a way generally. So that concept of, there's logic, there's schools of thought, people think differently, there's discourse. I get concerned sometimes that engineers get too narrowly focused on the nitty-gritty details of their engineering discipline, which is going to change over time. It's the ability to think, reason, discuss, come to consensus, and the ability to communicate. So those two things around the core, I think, are the three things that have helped me the most in my career.
That sounds really interesting, because a lot of the time you don't hear people speaking about the whole humanity side playing into like the tech industry. So because of that, I'm very interested in hearing what you think the arts and humanities, like what place those students have in the tech industry.
Well, in the tech industry, to begin with, is we tend to over-focus on it as, the engineers, but the vast majority, at least in the computer science tech industry, there's a large amount of employees or people in these companies that are not what you'd consider hardcore engineers. They're intellectual property lawyers, human resources professionals, communications, so corporate communications, both internally and externally, marketing and sales. So if you look at any moderately sized tech company, probably maybe a third of the team is actually hardcore engineering, and the rest of it is sales, operations, things like that around it. So there are certainly lots of careers for people who come from the humanities in those spaces. The thing that I encourage, which did not happen when I was in college, is that people that were humanities majors did not take basic science and engineering. So if you think about Columbia College, it was a little odd in the sense that the mathematicians and the scientists all were required to take the core curriculum humanities, but the humanities people did not have a core curriculum of mathematics and science. And it just helps when you go into the workforce if you have an understanding of the technology that your company's doing and evolving. And that's going to become even more pressing because we went sort of through three or four industrial revolutions. The first one obviously was the mechanical industrial revolution. Water or electrical powered machinery, construction equipment, railroads, it radically changed. We went from, people stopped doing tedious low-level manual labor. People stopped, manually working looms, and they were big. The computer revolution initially started out as replacing clerical. So it's actually interesting if you watch the movie Hidden Figures, you can see that there was an entire group of people that basically computers made them redundant. They were people doing human computations. Well, there were the same things happening in corporations. There were people that were just doing paper, pencil math, summing totals, doing the paperwork to transfer things. So all of that data automation, data processing, data clerks, that got replaced. And then you started to see it in the web. So you're starting to see it. It's still continuing in places like retail, where there's huge transformation because you can automate lots of the experience. The next one that's coming is going to, for the first time, start hitting what we would think of as knowledge workers, attorneys, accountants, because if you think about accounting, it is learning and applying rules. Computers are really good at that. And so as we start doing machine intelligence guided learning, a lot of the tasks that knowledge workers are doing today are things that are going to be automated. So we automated in the previous generation like the clerk data manipulation, but not the actually thinking about, okay, what's the right strategy for taxes? What's the right strategy for investment professionals? That kind of knowledge working is going to start to come under pressure. And those people are going to have to move up a level in the sense of their differentiation is going to be not understanding how to apply the rules, but understanding how to train the software to apply the rules in the way that they think is best. So the same sort of the same way, kind of as an analogy, a long time ago, an accountant would have done a lot of stuff manually. Well, part of his intellectual property now is having pre-built Excel spreadsheets that does do the things he wants to do. And then he goes and applies the rules. Well, he's going to have something that is the machine intelligence equivalent. He's going to have to figure out how to build that, tailor it, customize it so it expresses his way of thinking about taxes or finances. So that's going to be, I think, the next big wave. And that's going to require a level of comfort and understanding of computational technology that most people don't have. So I think that's the biggest next to change, is going to be in that space for the knowledge workers.
Yeah, I mean, it's very interesting that you say like 2/3 of the people in a company aren't even doing the engineering and the computer science. But then now it seems that you're saying that the people who are going to be valued the most with this whole change are going to be the computer scientists, that very fundamental computation.
Yeah, although I may have expressed myself inarticulately because the other groups will be equally valid, but for them to remain relevant, they're going to need to be much more comfortable doing something that today we would think of as a kind of programming. So the HR, these people use computers, but they don't program or tailor the behaviors of the computers. Now, it's not programming in the sense of Python, going down like the course you're taking Python, but it's more a case of higher layer definition of what you want the system to do. how do you guide the system to HR professionals today apply HR policies. So they understand what the policies are, they define the policies for the company, they figure out how to apply them in situations. They're going to switch to a mode where they spend more time thinking about what the company's policies should be, and then how do they configure the HR system to apply them automatically, as opposed to actually applying them themselves. So they're going today they train junior people to apply the policies. Tomorrow they're going to train computers to apply the policies.
So then is that going to be a complete loss of people's jobs? Like, are those jobs not going to exist, the jobs that the computers are doing, or do you think that new jobs will arise?
Well, I think new jobs will arise. There's always, if you look at the economic history of this, there's always a period of disruption, dislocation. But the fundamental element of normalized growth or normalized income is productivity. And so as productivity increases, other things open up. I mean, right now, you and I are having, neither you nor I is doing manual labor right now. And there was a period where there was this transition. I mean, my grandfather was a carpenter. He would have never dreamed. So you and I are doing jobs that they could not have even envisioned would have existed when my grandfather was fixing ships during World War II. And so, yeah, and it's always tempting to say, what are those jobs going to be? I don't know if I'd asked my grandfather in 1943 when he was redoing the inside of a ship what his grandson was going to be doing in 2018. I mean, he just would never have even conceived of this. So it's scary and it's tough for the people that get hit by the transition. But yeah, there'll be a whole jobs we never even dreamed of will come up.
Yeah, I definitely see that, but I would also see that perhaps your grandfather would say there'd be less manual labor and there'd be more people would need to think a lot more technically and stuff like that. I mean, I feel like
he might have, yeah. I mean, he might have, and so I've made some high-level generalizations about. I tend to think about by analogy and metaphor, and at least in terms in the knowledge worker space. When you become more experienced as an HR professional, a manager, an accountant, you spend a fair bit of your time training and guiding people. So you teach, you basically, if you're a manager of an HR department, you spend a fair bit of your time teaching the HR people how to apply the policies, giving them guidance. In the future, you're going to spend a lot more time training and teaching the system to do it automatically, not people. So it's almost like the case where we're going to evolve into a society where we mentor learning systems to automate and apply things. So, if I were an attorney, instead of mentoring a paralegal about how to do law and how the law works on here, I'm going to be mentoring a learning system to go and figure out how to apply the basic, legal stuff, how to go and generate the first draft of the will, as opposed to training the paralegal how to do it. So senior people in environments tend to train and guide junior people. A significantly larger part of that is going to be training and guiding machine learning systems to do the work.
Yeah, that makes sense. So then, other than the computational skills, there's also going to be this whole, you're going to have to be better at teaching and interacting.
Yeah, I think that's certainly true. You are going to have the computing skills to figure out how to guide and train the system, but you're going to spend, instead of applying policies, you're going to be spending a lot more time thinking about what the policy should be, what the rules should be. So you're going to be inventing more and applying less.
Yeah. So then how would you recommend someone prepares for that? Other than a computer science education, like how?
Well, computer science education My girlfriend summed this up. She's an attorney, and one of the first things they told her the first day of law school is, in law school they don't teach you the law. You can always just look that up in the law book. What they do is they teach you how to think like a lawyer. So there's a certain way of thinking. There's a certain mental process that you go through. Now, it's incredibly annoying when you live with one of these people because every argument gets litigated about who actually didn't put the dishes in the dishwasher starts to become litigated. And if you don't think like a lawyer, you lose every time. So it can be very frustrating. But it's not just hardcore engineering. It is good. And you can see that I try and emphasize this in the class is everybody comes to this class because they think they want to learn Python. And what I'm trying to communicate is no, because 5 years from now, there'll be some other language. What I'm trying to do is teach you how to think like a computer scientist, not teach you Python. Those are two radically different things. And learning to think like an engineer, like a computer scientist, discipline. So I, for instance, think philosophy would be a good thing, or linguistics, or logic. So it doesn't necessarily, need to be the hardcore, the engineering. It's the way to think. It's the way about solving problems. So one of it is just applying discipline to problem solving. There is also the core technology because you need to be conversant with it. It can't be overwhelming. You can't be afraid of it. People who are not exposed to it, who don't use it, who don't actively interact with it, tend to be overwhelmed by it. And when you become overwhelmed, you stop thinking. Panic, fear kills reason. So I think it's two things. It's a discipline about how you think, and you pick some of this up in computer science, you pick some of it up in mathematics, but you can pick it up in other spaces, linguistics, economics, philosophy. CC was a good place to pick it up, think things through. But yeah, you do need to have a basic foundation in computing and understanding computing technology, but you don't need to be a computer scientist. I mean, we all, maybe not you because you're young, but I grew up learning basic mathematics. I mean, we all learned how to multiply, divide, do long division, factor polynomials. But we weren't mathematicians. I mean, everybody learned that. So there's a basic core that you just need to possess to be able to be comfortable and conversant with the technology.
Yeah, that makes a lot of sense. So once you take all of this in and you make sure that you have this new way of thinking, do you think that any opportunities will arise in the future? What opportunities do you think will arise in spaces like the startup world and places like that with these changes in technology?
Yeah, well, I mean, every time everybody asks me that question, I'm tempted to tell them that if I could answer that question, I would be Jeff Bezos, not Donald Ferguson, or Sergey Brin, not Donald Ferguson. I'm flattered that you think I can predict the future with that level of accuracy. So startups, new companies, the machine learning, business intelligence, all of these hot topics, that space is saturated. I mean, it's virtually impossible at this point to go and sort of become a startup in that space because it's just so crowded. It's just hard to get any oxygen. So some things that I think are interesting that we really haven't touched on is I think that there's going to be a pivot and transformation in entertainment. The entertainment industry is ripe for disintermediation. You can start to see this happening. We are just beginning to come. Television and movies are great examples. Movies are already starting to get disintermediated, but these industries were structured around the fact that there was a limited channel to get the movie. So you had to go to a movie theater to see the movie, which meant that there could only be so many movies because there were only so many movie theaters. And so since you could only have a few movies, they had to make a lot of money. So you could never have a business where you made a lot of decent movies because there weren't enough movie theaters. There wasn't enough, way to get people to see them. Some of that television, to some extent, has been kind of the same way. First, they were limited broadcast frequencies, and then up until recently, if you wanted to get into somebody's house with television entertainment, you had to get picked up by a cable company, a distributor. Well, so if I'm going to produce something, I've got to go and get picked up and through a cable, and there's only so many hours on a cable channel, so you've got to figure out, which shows as a cable provider you want to host, and some of them have to. Whereas today on the internet, it's all peer-to-peer. Just any group of people that want to produce quality content, assuming they can find an audience, they can get the audience. So it's complete disintermediation, and you're beginning to see that with cable cutting and other things. That the aggregation has not stopped. It's not clear to me that it will, because there's still the dominant players like Netflix, Amazon Studios. But in theory, you don't need this aggregation layer of people that are sort of, I mean, if you think about it, you don't decide what you want to watch, somebody decides it for you. You can't go out and find interesting shows, support them. Public publishing, other medias, you're beginning to see some of this, self-publishing, but it's all in the very nascent. So I think a lot of it in entertainment, communication, that kind of thing, the middle layers are going to get disintermediated, and it's going to be much more provider and consumer directly interacting as opposed to going through aggregators. So I think that space of entertainment, communication, art is going to be an interesting space. I think that is significantly changed. I think we will see in disciplines, I mean, I tell you this in the class, which is, the first thing that happens when you have a problem is you go to Stack Overflow and you go figure out what everyone else has done. That pattern, I think, is going to apply all over the place. And the next generation is already doing this. And my daughter has, little pet rats, which are adorable. But like when there's a problem with one of them, people my age, our first reaction is to call a vet. Her reaction is go to the fancy rat, the pet rat owner forum and go see what everyone else has done. So this kind of self-community of sharing of information, I think there's a lot of opportunities in that space. Mostly because you can almost think of it as being like curation, because it's not that there aren't ways to find things on the internet. It's you've got to make sure that the things that you find are reliable, accurate. So that's the thing that's nice about Stack Overflow is people vote on them, people comment on them. But I think in general, the community-based support, the community-based knowledge sharing is going to be another big space that takes off. I think there's going to be something around mobile and peer communication. People are walking around with computers. You're probably walking around with an iPhone that has as much computing power as existed in the world when I was your age. But it's still all very hierarchical. So, you think about it, you use your phone, but most of the time you're connecting upstream to something. You're connecting to an upstream app like Amazon, Google. You're not really, but if a bunch of people in the room, they're not somehow using these phones to interact or collaborate. So they sometimes call it fog computing, which is as opposed to the cloud, where everything's up there and centralized. It's just the computing's just this fog that's all around you. I think that's an interesting space. there's a space, Internet of Things, the IoT. A lot of people talk about that. I mean, there's some startups in this space. That one, I think we are like at the very, very, very beginning of. Everything in your lifetime, I mean, everything is going to have some kind of computing in it. You know, it's not just going to be telephones and thermostats. I mean, it's going to be bottle caps, things you've never dreamed of. And that transition, I think, is an area, you know, is an area that's just ripe for innovation and change and dislocation. What we're doing with IoT, Internet of Things, is the next logical step. I mean, controlling thermostats and optimizing you know, which way the solar panels work, or, you know, I forgot to lock my door, check it on my cell phone. Those are, I mean, you think about it, which is, you know, 10 years ago, if you think you forgot to lock your door, you go call your neighbor and ask your neighbor, did you lock the door? Now you just call your house and ask your house, did you lock the door? I mean, it's a linear transition. Well, there's all kinds of things that are going to emerge that we just like never dreamed of. So I think that space is really potentially interesting. Computational medicine is probably another one. We have a relatively large number of techniques in medicine that we apply, but it's not highly tailored. I mean, an example of this is I've heard some stories about this. You know, I had a friend who, you know, had some psychological issues, and what they did is they put her in an MRI a few times to read her brainwave patterns and and then they had a giant database of people's MRIs, people's EEGs, and then what medications had been given to those people and which ones were effective. So it was extremely highly tailored. So if you go in, you know, to see a psychiatrist or, you know, a medical prescriber, they apply the same algorithm to everybody. Try this one first, then try that one. This didn't work, add that one. And they just keep going through until they find the combination. Well, this was highly tailored in the sense that, why do that? Go see how this person's brain compares to other people's brains and start with the combination that worked for these people. You'll see, I think you'll start seeing similar things in medicine, because physicians, medicine, they eventually get to the right answer, but, you know, you go into the doctor's office and they treat us all the same. And so I think that highly tailored computational medicine, I think is going to be an interesting space that's going to emerge. And then there'll be ones that I just never dreamed
of. Those are also really amazing examples. Yeah, so I mean, it almost seems like there's so many different examples that are going around. So if these jobs don't exist, do you think that it's better for people in the next generation to look towards creating companies more than looking for those jobs in particular? Do you think that that's a better option in the future?
Well, yeah, I think eventually I would still encourage people. I mean, I know people have been successful with it. I would not have been able to do a startup without having spent some time in a company. Yeah, the students that I have in my classes just amaze me. I've got freshmen that are in your class that come in and talk to me about the startups that they want to do, and I encourage them to do them. And there are mentoring programs, and there's startup mentoring programs. But when I was 18, I would have had no idea how to do it. And so spending some time in a corporation, if I were to do it all over again, I would have gone into the startup space a lot earlier, when I was a lot younger, but that doesn't mean I would have done it right out of college.
So then you still think that it's valuable to have that experience in the corporate world before you actually start create your own startup?
I think so, yeah.
So, I mean, if you were to take all of this information about, going into your job first and about what the future is going to look like, imagine you were in my shoes right now. You were taking Intro to Python at Columbia University.
Well, the first thing I would do is drop that course because
if you were a freshman right now, like what advice would you give yourself? What would you want Donald Ferguson to do so that you could be successful in the next 20 years?
Thing number one would be to take a basic nucleus of computing and mathematics classes. Exactly which those classes are, I need to think about it a little bit. The title of the course you're taking is actually Introduction to Computing Using Python. It's not Introduction to Python. Those are two radically different things. And I mentioned that on the first day. I'm not trying to teach you how to program in Python. I'm trying to teach you how to think like, solve problems with computers. So there's a set of courses that Computing in Context, which is one of the ones that Columbia offers for people that are less inclined. Data structures, basic algorithms, some basic mathematics. I think a basic understanding of physics and chemistry is useful. I mean, I'm not sure you need to spend 4 semesters in physics and 4 semesters in chemistry, but we need to find a median or the middle way. I don't know what it's like, in Columbia College now, but there was a science requirement in Columbia College, and we had all these courses that we called like Rocks for Jocks and, Physics for Poets and that kind of thing, where people would satisfy their science requirement, but effectively not learn any science. And so we need to find something in between. And even if it's just a basic year of core science, you spend a little bit of time doing physics, a little bit of time doing chemistry, a little bit of time doing, geology, or just basic understanding. Some other things completely out of the box is learn to speak a second language. I think the ability to speak a second language and to interact with people that don't come from your culture is useful. So I would encourage people to learn a second language. Would be, I think political science is very useful. Not necessarily because of the fact that corporations are inherently political entities like anything else, but we live in a very complex world of interacting entities, companies, non-government organizations, governments. And so basic understanding of politics, systems, how things interact, I think would be useful. I think a basic economics course is a good thing. And probably a philosophy course. I would encourage people to take a philosophy course.
That makes a lot of sense. With regards to the computer science classes,
the other thing I would tell them is don't worry, because at your age, these seem like life or death decisions. Like, do I take this course or do I take that one? They're not life or death decisions. I've got a daughter that's in college, and I need to keep reassuring her that nobody ever asks me what I got in 4th semester calculus for a grade. Or, I mean, I don't even remember. I'm sure it's on my transcript somewhere, but it seems like life or death, but it isn't.
Yeah, I mean, it sounds really great. And it seems, I mean, you've given a lot of great advice for the students, but then there are also some university staff who are listening. And I was just wondering what you think. Since you're a father, you are kind of guiding your daughter in the same way that these university staff are guiding students.
That's spoken like somebody who never had a child.
Yeah, well, I mean, how would they go about ensuring that their students are effective? I mean, because you are also a faculty member. So
universities, Universities shape behavior that I understand why they do it, but I think it's historical. I mean, you've seen this, the concept of, an in-classroom exam in most environments doesn't make any sense. And I was in corporations for, I don't know, 35 years. Nobody ever put me in a room, gave me a blue exam book and a pencil, right? That's why I give take-home exams. The world isn't closed book. Right? It's like, if you don't know something, you go look it up in a book. You don't go in and sit down and then have to close your chemistry book. That's just not the way it works. Now, I can understand the difficulty of measuring performance, what they've learned by any other system. But the way we do exams, the way we determine grades is just not a good preparation. The ability to cram and study for tests is not really applicable outside of a university. It is a very perishable skill. So I think universities need to do a better job of measuring student performance. I understand you need to have grades. I mean, you work in a corporate world, you get a performance appraisal. Sad fact of life, but you get graded. You get graded in life, but it's not a take-home closed book. It's not a closed book exam, but you get graded. So I think the schools in general can do a better job of shaping people to function in a system that has grading, but is not as distorted as the academic one is. So that I think is one change. The second one that I observe is, and this one, even corporations don't do a very good job of this. I would always try and make this point when I was an executive, is failure is inevitable. Failure, I mean, I got to give my father credit. I mean, I took a midterm math test when I was a sophomore, and I called him up and told him I thought I failed the test, and his response was, "I hope you did fail the test." And I remember vividly taking the phone away from my ear and looking at it because I couldn't believe what I'd heard. And then I kind of asked for an explanation, and he said, "Well, you're going to find out that it's not the end of the world if you fail a test." I mean, if you think about the space program, I mean, things blow up, but you still get to the moon eventually. And so I don't think we do a good job of understanding that in some ways you learn more from failures than you do from success. So that's part of the reason you've noticed in the course that I've told everybody there's a path to an A, which is if you lose point on homework or on exams, you make it up on extra credit. You're going to learn more from the points that I take off your homework than you are from the homework itself. So as long as there's a way to grow and learn from that experience, I think that you learn more from what you get wrong than what you get right. And universities, schools in general don't, do a really good job of that. So I think that's the second thing. There is not enough emphasis on writing and presenting and simulating social experiences. Engineering, software development, law. There's a reason why when you watch a legal drama, there's so much time spent in conference rooms. That's the way it works. I spent, this computer scientist engineer, spent a lot of time in conference rooms and meetings. I don't think we do a particularly good job of that. Our classes are all some guy up in the front of the room talking and a bunch of other people sitting there either using their iPhone or taking notes and that kind of structure. So there are a fair bit of things that we can do differently.
Yeah, that makes a lot of sense. You've given like a lot of really great advice, and The only thing is we can't always have Donald Ferguson like every year. We can't have you come and we listen to what you have to say. So how do the staff actually keep asking the right questions? How do they keep predicting the future? How do they keep understanding how it's going to change for their students?
That's a really good question. I mean, the presumption of your question, first of all, the underlying presumption of your question is that the information I communicated was useful. And so it's far from clear that that was the case, but I'll accept the premise of the question that yes, what I communicated was useful. I would say self-study. A large part, yeah, I think self-study. I mean, the people that are on this call are, you know, smart, talented, caring people, committed. I mean, educators by definition are committed to, you know, to students. I mean, my mother was a teacher. You know, I see my kids' teachers in school. I mean, I routinely will say there's nothing more valuable than a good teacher. I mean, you go look up. I mean, my kids take this science research program, and it's, you know, you go look up the salary of the guy who runs the science research program, and your first reaction is, okay, there's a zero missing at the end of his salary. I mean, it's just ludicrous. I mean, his value to society is just he's not compensated. So most of what I've talked about is out there. I mean, it's self-study, it's understanding where to find it. Also self-organization. I mean, the people on this call, you know, can organize and share their experiences and communicate. That's actually a lot more effective than just sitting here and listening to me talk. So I think enablement, either just self-enablement through study and learning, or collective enablement through forming groups, special interests. That's something I learned as an executive in tech companies. One of the first things that I would do is I would set up special interest groups in the engineering community so that people who are doing things could get together, could talk about it, could share ideas. And so special interest groups focused on certain topics was by and large the most successful thing that I could do to help an engineering team be more productive. So it wasn't leadership and guidance for me. It was just basically putting people in contact with each other so that they could share their experience, their strength, their hope, what worked, what didn't work. So yeah, you see that user groups in computing, you know, local startup communities. So forming groups and helping and enabling each other, whether it's an electronic group or an in-person group, I think is also something that can be very valuable.
Yeah, that makes a lot of sense. Well, I feel like you've answered a lot of questions very well. Thank you so much for coming and speaking with us.
I'm happy to do it.
Yeah, thank you so much. I just want to remind, yeah, be sure to look out for HR Uncubed, HR Entry, and our 2 webinars that are also coming up. So thank you so much, Donald Ferguson.
It was a pleasure, and do your homework.
Yeah, I definitely will. Thank you.
All right, bye-bye.
All right. Cheers.